Hi everyone, I am Rebai and I recently earned my PhD in Environmental and Infrastructure Engineering from Politecnico di Milano. Over the past few years, I have focused on sediment transport, the movement of granular particles like sand and gravel carried by water and wind. This process is critical in shaping our landscapes, rivers and coastlines. It also has significant implications for flood risk, hydraulic structures, and environmental health, since sediments often carry nutrients, contaminants, and pollutants. Alongside my supervisors, Francesco Ballio and Alessio Radice, I explored the measurement and modeling of sediment flow rate. The study of sediment transport has been ongoing for decades, with crucial contributions made at the beginning of the last century. For example, Kalinske and Einstein developed conceptual models that could not be experimentally verified at the time. Here, I discovered that classic models, which seem different, are two ways of averaging the same equation, the local instantaneous mass flux. Today, more advanced measurement techniques allow for increasingly detailed investigations. I measured bedload motion using particle tracking velocimetry. If I use particles of different colors, it's easy to recognize black particles moving among white particles. On the other hand, if particles look all the same, I use the technique called image subtraction. Here, you can see few frames grabbed from this video. Nothing moves but me. Thus, in the difference of images, you can recognize my figure only. One of the key challenges in sediment transport measurement is determining whether a particle is truly in motion or not. Particles often alternate between moving and resting, and some may jiggle in place without contributing to actual downstream movement. In my work, I developed a new criteria to classify particles into three states: stillness, transport, associated with downstream movement, and non-transport, associated with particle jiggling. I then studied how these states affect the overall sediment transport process. To better understand the role of turbulence, the chaotic and fluctuating nature of water flow, I conducted experiment at the Technical University of Braunschweig. By adjusting the level of turbulence in a flume, I measured how flow velocity, bare shear stress, and sediment motion interact. Our results showed that when turbulence increases, more particles move and they travel faster, resulting in a greater sediment transport, even if the average shear stress remains the same. Thank you for watching, and I hope that this video gave you some insight into the fascinating world of sediment transport and the science of scenery.